Hey guys, welcome to lesson 6.1. We are going to talk about some new right triangle stuff, and the first thing we're going to talk about with regards to that is the tangent ratio. So before I necessarily introduce the tangent ratio itself, I want to talk about where it comes from so that you kind of understand it a little bit better. And we're going to do that in terms of slope triangles. So what a slope triangle is just a right triangle drawn between 2 points on a line, and the height and base of that triangle are actually like the rise and the run of the line's slope. So here I have a picture that has 3 slope triangles on it for 3 different lines, and so you can see that this triangle starts here at a solid point on the line, right? It's like a nice corner point. It's not anywhere like in between boxes, and then it goes all the way up to this point, which is also a solid corner point, not between any boxes. And slope triangles, like, you can make them bigger, you can make them smaller, you can go from, between any solid points, but the angle and the ratio will stay the same, but we're going to talk about that in just a little bit. All right, so these are your examples of slope triangles. Okay, notice how when we drew this right angle, or right triangle, now the height is the rise for the slope because, that's the vertical change from one point to the next. And then the base is the run, which is the horizontal change from one point to the next. Okay, so the slope angle is the angle that's created between the line in question and then the base of your slope triangle. So this is a slope angle, this is a slope angle, this is a slope angle. All right, all of these are considered slope angles, and just remember again, they're between the line and the base of your slope triangle. Okay, it's also worth noticing that the hypotenuse of your triangle is always on the line that we have graphed on this graph. Okay, and lastly, we have the slope ratio. Now, this is the really important piece, and what the slope ratio is literally just like the rise over run that we're used to from Algebra 1, okay? It's the rise over the run, so which is basically just the slope, and what that is in terms of slope triangles is it's the height over the base, over base of the slope triangle, okay? So here, for example, I have a rise or a height of 4 boxes, and I have a run of 2 boxes, so my slope ratio is 4 over 2, which really is just 2 when you divide those. Okay, here I have 4 boxes in the height and 4 boxes in the base, so this slope ratio is 4 over 4, which is equal to 1. Okay, this one I have a height of 2, a base or a run of 4, so this one is 2 over 4, which is also equal to 1/2. Okay, so that is all about slope triangles and slope ratios, and we're going to use that idea to develop the tangent concept. Okay, so let's look at a couple of slope triangles here and make some observations. We know that the slope angle right over here, as I've told you in the picture, is 11 degrees. And the slope ratio, again, is the height over the base of that slope triangle. So in this case, it's going to be 1 over 5. Okay? And when you actually do 1 divided by 5 in the calculator, you'll get a decimal. And I want us to actually pay attention to those decimals. So we get 0.2. So I will write 0.2 here. Okay, and again, I do want to take a moment to point out to you that even if I had made a larger slope triangle, let's make it with our line tool. Let's say I make this nice big slope triangle. Obviously, this is a bigger version of that small one. If I were to use that to find the slope ratio, I would have a height of 2 here, and I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. Okay, so if I used this triangle to make my slope ratio, I would have 2 over 10, which, if you simplify it, is the same as 1 over 5, which is still 0.2. Okay, so my point here is that even if you make bigger slope triangles, it doesn't matter because that ratio is going to stay the same. All right, so let's look at another one. Here I have a 22-degree slope angle. And the slope ratio, I have to draw my slope triangles first. So here's one, here's one. All right, I could make the big version if I wanted to. All right, these are all valid slope triangles. And so let's use this one to find our slope ratio, right? This has a height of 2, and this has a base of 5. So my ratio is going to be 2 over 5. And if we type that into the calculator, we will get a decimal of 0.4. Okay, so that's what we're going to write as our decimal version. All right, one more. We have now a slope angle of 45 degrees. And the slope ratio here, I have to draw my triangles. So here's a triangle, here's a triangle. These are all triangles. I can even do a bigger triangle like this, right? If I did that one, I would have 2 over 2. If I did like this tiny one, I would have 1 over 1. Really, my slope ratio is 1 over 1, which is just equal to 1. Okay, and of course, if we use this triangle, we would have 2 over 2, which is still equal to 1. So again, doesn't matter which triangle you use. Okay, so now that we've done this, let's go ahead and go to the next page and take a look at this tangent concept. In your calculator, and I don't know how many of you guys have a calculator, but I will have you download the free TI-84 that TI is offering us for Chromebooks for virtual learning, and the link for that is available on my general information tab in my Open Math. Let me know if you need help finding that. But it's going to be this button on your calculator, and we are going to go ahead and calculate the tangent of all of these angles. Okay, these angles should look familiar. They're the same slope angles from the last page. So let's go ahead and do that. We got tangent of 11. That tan stands for tangent. All right, we get 0.194, all this long decimal. But if we rounded this to 1 decimal place, because that 9 is like 5 or bigger, this 1 would round up to a 2, and so we would have here 0.2. Okay, let's do the next one. Tangent of 22. That gives us 0.404026, all this long decimal, but again, if we rounded to just the first decimal place, that gives us a 0.4. So that's what we'll write here. And lastly, we get tangent of 45. I do apologize if you hear a lot of background noise. That's my family in the kitchen. Tangent of 45 is going to equal 1. Okay, so hopefully these decimals, or well, in this case 1 isn't a decimal, but hopefully these numbers look familiar, right? When we just took the tangent of these slope angles, we got the exact same numbers, right? 0.2, 0.4, 1. So this is a shortcut, okay? This is why we have seen the answers before. They're from the previous page, right? So really, what's the tangent ratio? Well, it is really just the slope ratio. Okay, so essentially what the calculator is doing is that it knows what the ratio is for every single angle, every single slope angle in existence. All right. Okay, so really tangent is the rise over the run. So let's see what this looks like in action here. This is just to get our feet wet. Here I am asking you to find the tangent of angle A. And so, so now if I'm finding the tangent of angle A, here's the thing. We need to look at this as if angle A is the slope angle. So it would probably be helpful if we rotate this triangle so it looks a little bit more like the triangles we were working with on the last page. It's going to be really rough. I'm trying my best. All right, so let's go ahead and take this triangle and rotate it so that angle A is very obviously our slope angle. Okay, so I've just copied over the information from that triangle. And now we can see that when A is the slope angle and we have these other lengths like CB is 6, AB is 15, and AC is 9. So the rise over the run is going to be 6 over 9 because 6 is the height and 9 is the base. And that's because we have chosen A to be the slope angle. Okay. Number 2 is just asking to find the tangent ratio when we know that the slope angle is 30. Remember, we just learned that if we have the slope angle, we don't actually need the sides to find what the tangent ratio is. We can just use the fancy tangent button in our calculators. And in this case, we found that it was 0.577, so let's just call that 0.58. So I did tangent of 30, and that ended up being about 0.58. Okay, what that's saying is even though we don't have these two sides, this is the ratio that we would have between the two, no matter what those two sides are. All right, and one last problem. This one really is just to get our feet wet. We're going to talk a lot about this process a lot more tomorrow, but I do just want to expose you to it. So right triangle trig is used frequently to find the missing side of right triangles, okay, and this is granted that you have the slope angle and then one of the other sides. So in this case, we know that the tangent ratio or the slope ratio would be equivalent to 10 over x, right, because this is the height, this is the base, and that's what we know the tangent ratio to be. Now we also know that this ratio is equivalent to the tangent of the slope angle. So we know that whatever x is, it's something so that when we do 10 divided by it, we get the same answer we would get when we do tangent of 20 in our calculator. So I'm allowed to say that these two are equal to each other, and I'm going to go ahead and put this one over 1 because you're allowed to do that for anything, really. Every number in the world has an imaginary denominator of 1 because when you divide by 1, it doesn't do anything to your actual number. And the reason that we're doing this is not just for fun. We're doing it so that we can create a proportion and cross multiply to solve for this x value. So here's one diagonal. Here is my second diagonal. Okay, and you have to treat tangent of 20 just like any old number. I know it's uncomfortable because it has letters in it, but it really is just representative of a number, right? It just hasn't been popped into the calculator yet. Okay, so when we rewrite this after cross multiplying, we get x times tangent of 20 is equal to the other diagonal, which is 10 times 1, which is just 10. And now we have to solve for x. Now, again, the way you do this is the same as if you had any other equation, right? Imagine if I had 4x equals 10. Right? To solve this, I'm sure you all know that you would divide both sides by 4, right? To get this 4 away, and you get an answer of 10 over 4. This is the same thing, okay? We want to get x alone, and it's being multiplied by the tangent of 20, so we're actually going to go ahead and divide both sides by the tangent of 20. And again, we can do that because tangent of 20 is just representing a number, right? So when you do it on the left, it cancels out, so our answer is going to be whatever you get when you do 10 divided by tangent of 20. Okay, and again, this is irrelevant to us. This is just an example that I made for you to understand how to solve this, but it has nothing to do with this actual problem. All right, so this is what we're going to type into our calculator. You're going to do 10 divided by tan of 20. I'm going to make this big so y'all can definitely see what I typed, right? Right here, 10 divided by tangent of 20. We're going to press enter, and we got an answer of 27.47. So we'll say 27.5 is our answer. Okay, so what this tells us is that this side length of this triangle is about 27.5. All right, give the quizzes practice problems a try.